Hey guys, it's day 8 of 100 days of DSA challenge and we are back with another medium level question on Leetcode. This is Leetcode 402 remove k digits. So this is a pretty simple looking question, but it's not that simple. I'll tell you why. So basically we are given a string num and it represents a non-negative integer num, and we are given an integer k, and we have to return the smallest possible integer after removing k digits from num. So for example, this is the given string num and this is the k. So we have to remove k digits from this num. So we have to remove 3 digits from this num, and we have to return the smallest possible integer. So guys, see, we cannot rearrange these like the order of the elements in the string. So we cannot just put 4 forward. So you can't just sort this string like, okay, you think that I'll just sort the string 1 2 2 1 and I'll remove the last 3 elements. You cannot do that. You cannot change the order. You have to return them in the same order, and you have to remove certain elements, k number of elements. So the answer for this is 1219. So basically we remove 4 3 1 2, and yeah, we remove the 3. We basically remove these 3, and uh, the remaining is our answer. So how do we do that? Well, the logic for this question is very similar to the previous questions we have done, but yet it took me a while to figure it out. But here I am with the solution. So we are going to do it again with the monotonic stack. I'm sorry, I know I said that I'll do Q questions now, but I thought that I'm not that strong with stacks yet, so it's better to, master the stacks first. Anyways, so let's just start. Alright, so this is the given input, and we have to return a string after removing the k elements, the smallest possible string we have to return. So we will take a stack and we will say, okay, this is the current element. Stack is empty, let's just push it, okay. Then this is the next element. Now, okay, let's imagine that this is our number here in the stack. So 1 is our current number, and then we get to 4. So what can we do? If we remove 1 and get 4, then does that make sense? No, it does not, because we want the smallest number at the beginning, right? We want the smallest number at the beginning, and we want the large numbers to be eliminated. So my approach is to simply erase those large numbers, okay, and just keep the small numbers in the starting. So 1, so removing 1 to get 4 does not make sense, so I'll just push 4 into this. Now we get to 3. Now the current number is 1 4. Now, does removing 4 to get 3 make sense? Yes, it does, because now the number will be 1 3, and 1 3 is smaller than 1 4 or 1 4 3. So yeah, I'll just do that. I popped 4 out of it, and whenever I'm popping an element out of it, I'm just doing k minus minus, yeah, so that I keep a track of the number of elements I have removed. So now the next number for us is 2, and our current number looks like 1 3. Here comes 2. So now does removing 3 to add 2 in the number make sense? Yes, it does, because if we remove 3 and add 2 to it, then the number is 1 2. And what did I say before? That I wanted the smallest numbers at the beginning. So yeah, this is now 1 2. We pop 3 out of it. Now we come to 2. Now does removing 2 to add 2 make sense? No, it does not, because it does not change our number. Okay, 2 is also a small number. We want 2 to be in the final answer. So we do not pop 2 out of it. Instead, we simply push 2 into the stack. So now our number looks like 1 2 2. Then we come to 1 and k minus minus. So currently we have removed 2 k's. We come to 1. So is 1 smaller than 2? Yes, it is. So does removing 2 to add 1 to it make sense? Yes, it does. Because now our number will begin with 1 2 1. Okay, and with this I have removed 3 k's. As soon as I removed the 3 k's, see, in the question we were given that we had to remove 3 k's. Okay, so as soon as I remove 3 k's, I will stop and I'll simply push the next element into the stack. Okay, until this string is empty. Okay, so even if there were numbers like 1, 1, 2, 3, 9, any number after this, whatever the number was, it will always begin with what we came with, which is 1, 2, 1, 9. Okay, these three were removed. So even after even if the numbers were 1, 1, 2, 3, 9, anything after this, this will be the smallest number. This will be the beginning of the number which will be the smallest. Alright, this is the approach. Now let's see how we can code this. So, alright, let's see how to code this. So I've taken a stack of character type and I am iterating to the string while the stack is not empty and k greater than 0 and stack stop is greater than nums_i, which is the current element of the string we are iterating. We are popping the stack, we are doing k minus minus, as simple as that, and then we are pushing the, after we are done with this, we are pushing the element into the stack, as simple as that. Now what are these edge cases I have written? Now you will notice that it is a possibility that the stack would be empty after this operation, this whole operation. It is possible that for certain test cases the stack is empty after these iteration. As you can see here, in this iteration the stack will be empty after our operation. So what do we do in that case? We simply return 0. It is said that we have to return 0 in this case. Okay, so with that our first edge case is resolved. Let's see the second edge case. It says that if k is greater than 0. Okay, so there's a possibility that let's say if the numbers were arranged in a certain order, like let's say if they were arranged in descending order or ascending order, let's say if there were 1, 2, 3, 4, 5, 6, and let's say the k was 2. Okay, so when you will apply this algorithm on this specific test case, you will see that you will simply get the answer like 1, 2, 3, 4, right? Because the next element is never smaller than the previous element, which is the stack stop. Therefore it will keep increasing, and hence after the whole iteration of the string the k will not become 0. So what do we do in that case? Well, in that case it is guaranteed that the elements at the last are the greatest. So we are simply going to remove k number of elements at the last. So in this case we are simply going to remove 5 and 6, and this is our smallest possible integer. As simple as that. Alright, so that is what I have written, that while k is greater than 0, simply pop the stack and k minus minus. That's it. Now we have taken an answer string which we have to return, and while the stack is not empty, I'm simply pushing the elements out of the stack into our answer string. That's it in this one. And after popping our stack and pushing all the elements into the string, you know that it's in the reverse order, right? So if this is the stack 1, 2, 3, 4, we are popping elements out of it and pushing it as answer. The answer will become 4, 3, 2, 1. But we do not want 4, 3, 2, 1, we want 1, 2, 3, 4. Therefore we will reverse this. So that is what I have written, that after pushing all the elements out of the stack, we are simply going to reverse our answer string. Now comes our third test case, our third edge case. I know there's a lot of edge cases in this question, that's why it is a medium level question. So what we are going to do in this test case is that if there are zeros at the beginning, which is this test case. So in this test case they removed 1 out of it. We just had to remove 1, so they removed this 1. Now after they removed 1, the string must be left to 0, 2, 0, 0. But is that a valid string? No, it's not a valid string. Therefore, because there's a 0 at the beginning and there can be n number of zeros at the beginning, we do not want that. So what we are simply going to do is, as long as there are zeros at the beginning, we are going to pop them out. It's that simple. It doesn't matter how many zeros there are at the beginning. We can simply write that as long as there are zeros at the beginning, while our answer is not empty, because there's a possibility that it will become empty, right, after popping, and answer dot front equals 0. As long, and guys notice that this is in single quotes because it is a character. Okay, each element of the string is a character, so that's why it is a single quote. So as long as our answer is not empty and answer's front equals to 0, we can erase answers beginning. As simple as that. So if it is 0 2 0 0, then I'm going to check is answers front equal to 0. Yes, it is. So I'm going to erase answers beginning. So this 0 will be removed, and now we are left with 2 0 0, and that is what we wanted. As simple as that. Now the last test case, I promise guys. That's why I've written 3.2, because it is a possibility that we got a string in a test case where all the elements were 0. Let's say this was the answer string. So after applying this particular code, the stack will become, I mean the answer string will become empty. And what do we do when the answer string becomes empty? We return 0. Alright, we return 0. So I'm just saying that if there's a possibility that answer is empty after removing of zeros at the beginning. So I'm just saying if answer is empty after all this, just return 0. And after that you simply return answer. Well, I believe this is a really good question to, question your logical thinking and make you really think about all the possible test cases, because it's like a story going on. After every test case, the scenario is different and you have to imagine it. So go ahead, guys, grab your copy and pen and solve this question, dry run this question, and do it again and again until you get it. So see you on day 9. Thank you for watching.